The National Electrical Code, or NEC, does not mandate heaters for every motor type and size. Motor heater installation becomes essential when motors are prone to condensation, which can compromise motor insulation integrity. Specifically, motors situated outdoors or those undergoing frequent start-stop cycles typically necessitate heaters. Determining the appropriate heater size hinges on both the motor's dimensions and the surrounding ambient temperature. Article 430.32b within the NEC offers guidelines for selecting the right heater. As a general rule, a heater possessing a wattage rating ranging from 1 to 5 watts per square foot of the motor's surface area is usually adequate. Always adhere to the manufacturer's guidelines during the installation and operation of motor heaters. Incorrect installation or usage could potentially lead to fires or other dangerous situations. Motor heaters play a crucial role in preventing moisture buildup within electric motors. Condensation can form when a motor cools down, particularly in humid environments or when the motor is exposed to temperature fluctuations. This moisture can then lead to corrosion, insulation breakdown, and ultimately motor failure. Therefore, understanding when and how to use motor heaters is essential for ensuring the longevity and reliability of electrical equipment. The NEC provides the framework for safe electrical practices, but specific applications often require engineering judgment and adherence to manufacturer recommendations. Factors such as the motor's environment, operating cycle, and criticality of the application should all be considered when deciding whether or not to install motor heaters. Let's delve deeper into the circumstances that necessitate motor heaters. Firstly, motors located outdoors are prime candidates for heater installation. These motors are directly exposed to the elements, including rain, snow, and humidity. The temperature variations between day and night and between seasons can create conditions ripe for condensation. Secondly, motors that experience frequent starts and stops are also susceptible to condensation. When a motor is running, it generates heat. When it stops, it cools down. This cooling process can draw in moist air, leading to condensation inside the motor. Thirdly, motors operating in humid environments, such as near bodies of water or in industrial facilities with high humidity levels, should be equipped with heaters. The high moisture content in the air increases the risk of condensation forming within the motor. Fourthly, motors that are idle for extended periods are vulnerable to condensation. When a motor is not running, it is not generating heat, and the internal temperature can drop, increasing the likelihood of condensation. Fifthly, critical motors, where failure would have significant consequences, should be protected with heaters. These motors may be used in essential services such as pumps, fans, or compressors, and their reliable operation is crucial. Now, let's explore the different types of motor heaters available. Firstly, space heaters are small resistance heaters that are installed inside the motor enclosure. They generate heat to keep the internal temperature of the motor above the dew point, preventing condensation. Secondly, strip heaters are long, thin heaters that can be attached to the motor's frame or end bells. They provide a more uniform distribution of heat compared to space heaters. Thirdly, silicone rubber heaters are flexible heaters that can be wrapped around the motor's windings. They provide direct heat to the windings, which is the most critical area to protect from condensation. Regarding the selection and sizing of motor heaters, several factors must be taken into account. Firstly, the motor's size and surface area are important considerations. The heater should be sized to provide adequate heat to the entire motor. Secondly, the ambient temperature range is also a crucial factor. The heater should be able to maintain the motor's internal temperature above the dew point even during the coldest periods. Thirdly, the motor's operating cycle should be considered. Motors that experience frequent starts and stops may require more powerful heaters. Fourthly, the heater's wattage rating should be selected based on the motor's size, ambient temperature, and operating cycle. The NEC provides guidance on heater selection in Article 430.32b. But it is always best to consult with a qualified engineer or electrician to determine the appropriate heater size for a specific application. Installation of motor heaters should be performed by qualified personnel. Firstly, ensure that the power supply to the motor is disconnected before starting any work. Secondly, follow the manufacturer's instructions for installing the heater. Thirdly, properly connect the heater's wiring to a power supply. Fourthly, verify that the heater is functioning correctly after installation. Finally, regular maintenance of motor heaters is essential to ensure their continued effectiveness. Firstly, inspect the heaters regularly for any signs of damage. Secondly, clean the heaters to remove any dust or debris. Thirdly, test the heaters to ensure that they are functioning correctly. Fourthly, replace the heaters if they are damaged or not functioning properly. In addition to the NEC, other standards and guidelines may apply to motor heater installation. Firstly, the National Electrical Manufacturers Association, or NEMA, provides standards for motor design and performance. Secondly, the Institute of Electrical and Electronics Engineers, or IEE, publishes standards related to electrical safety. Thirdly, local codes and regulations may also apply. It is important to be familiar with all applicable standards and guidelines before installing motor heaters. Understanding the principles of condensation is crucial for understanding the need for motor heaters. Condensation occurs when warm, moist air comes into contact with a cool surface. The air cools down, and the water vapor in the air condenses into liquid water. The dew point is the temperature at which condensation begins to form. The higher the humidity, the higher the dew point. The temperature difference between the motor's internal temperature and the dew point determines the rate of condensation. The greater the temperature difference, the faster condensation will form. Preventing condensation involves keeping the motor's internal temperature above the dew point. This can be achieved by using motor heaters, which generate heat to warm the motor. Another approach is to ventilate the motor enclosure, which allows moist air to escape. However, ventilation may not be sufficient in humid environments or when the motor is exposed to temperature fluctuations. Motor heaters are a reliable and effective way to prevent condensation and protect electric motors from damage. In summary, while the NEC doesn't universally mandate motor heaters, their use is crucial in environments where condensation is likely. Proper sizing, installation, and maintenance are key to ensuring their effectiveness and preventing potential hazards. Always consult with qualified professionals and adhere to manufacturer guidelines for safe and reliable operation. This approach safeguards your motors and extends their lifespan, minimizing downtime and maintenance costs. Remember to consider the specific operating conditions and criticality of the motor when making decisions about heater installation. A proactive approach to motor protection is always the best strategy. Understanding the nuances of motor heater applications can significantly improve the reliability and efficiency of your electrical systems. And always prioritize safety by following established electrical codes and best practices. By paying attention to these details, you can ensure that your motors are protected from the damaging effects of condensation and that your electrical systems operate safely and reliably. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with qualified engineers and electricians for specific applications and to ensure compliance with all applicable codes and regulations. Continuous learning and staying updated with the latest industry standards are essential for anyone working with electric motors and electrical systems. Embrace a culture of safety and continuous improvement to ensure the reliable and efficient operation of your equipment. By investing in motor protection and proper maintenance, you can minimize downtime, reduce costs, and extend the lifespan of your valuable assets. Also remember that the NEC is a living document and gets updated. Make sure to stay on top of these changes and improvements.